Hey, what's going on, everyone? So this begins week 2 of CMIS320, and this week we're going to be focusing on the entity relationship model. So let's take a look at that, where it's also referred to as the entity relationship diagram. So let's take a look at the concepts of these diagrams. The ERD should capture three things. It should capture the entities and the attributes and the relationships. Now, I've mentioned to a few of you that right now we are in the development portion of building our database. So we are not working with tables, we're working with entities. Now, as we'll discuss here in just a little bit, those entities do not necessarily translate directly to tables later on, but we'll see that here in a few weeks. But like I said, since we are doing development and building models to depict our database, we are working with entities rather than tables. And the attributes are the characteristics of those entities, and then of course the relationships are the relationships between the entities, and it shows how those entities tie together. And the ERD, now the ERD, by the way, is supposed to be a conceptual model that is to be presented to primarily, hopefully starting at the top, to the management of the company, and then to the end users later on, to kind of demonstrate to them how everything is going to work, how all the data is going to tie together, and who's going to own what data, and so on and so forth. So that being the case, it's really, really important to have that ERD as simple as possible. So now we still need to make sure that we capture all the requirements and identify all of the entities that are going to be needed, as well as the associated attributes and the relationships, but we still need to make that quite simple. And again, this translates later on very well to the resulting database. So with the entities, we start with as few entities as possible to capture what the database needs to do, and make sure that we identify all of the data that will be contained therein. Now, one important point is that each item that is going to be stored in an entity is not a record. Again, we're not working with a database. That is it's merely an instance of that entity. So again, we're not working with tables or records of tables. We're working with entities and the instances of those entities. So, as I've mentioned, those entities should be of a singular noun. Don't have entities named employees or students or instructors or anything like that. It should be a singular noun, and the title should have the first character capitalized and the rest of the characters lowercase. And now, since we're just doing the modeling for this database, as I mentioned, those entities do not necessarily translate to tables later. We'll see how that converts a little later on in the class, but do not equate the entities directly with tables at this point. So here are a few types of entities that we're going to focus on in this class. We have strong entities, which are the primary types of entities that we're going to be dealing with in this class. Now, by the way, this the text in Books 24/7 has a particular type of format for that ERD with attributes kind of hanging out to the side. So let's not work with those. Let's deal with this type of format where we have an entity with a title at the top, and the primary key is going to be underlined, and then you have all the underlying attributes under that. Now, we'll see later on that we'll have the primary key underlined, and then we'll have PK in parentheses out to the side of the primary key as well. But just make sure that in each entity, it doesn't matter if there are 40 attributes in one entity. Let's just keep everything contained in the same block. So it's not all dispersed all over the place. It looks a lot neater doing it that way. So I digress. Again, this is the strong entity on the left, named employee, and then the weak entity is over here on the right, which is dependent. And it's a weak entity because it doesn't have a primary key on its own. It has it kind of is associated with the employee. So in other words, you wouldn't have a dependent if you didn't have the associated employee. And we talked about briefly, there was some discussion about bridge or composite entities, and Ed, I believe, actually did a pretty good demonstration on how this works. Now, I've mentioned before that when we're going from our model to our actual database design, you can't really you can't build a database that has a many-to-many relationship between your tables. So in the modeling, we're going to eliminate that by we identify what our entities are, and we'll see between order and product we have a many-to-many relationship. Now, in order to get rid of that, we build another entity, and this is our bridge entity. Now, notice the difference in shape between these entities. We have kind of for the strong entities we have squared corners, and then for the bridge or composite entity they're rounded corners. And you'll notice that with these relationships, you'll see that this is now a one-to-many and one-to-many relationship between the strong entities and the bridge entity. So attributes. Now this is very important. I saw a few people make a few mistakes on these attributes and actually use values that might be entered in those attributes in the attribute names, and we can't do that. Attributes are going to be characteristics of the entities rather than the values that might be entered in those attributes. We'll get into defining domains and all that kind of stuff for the values a little later on. One attribute should be an identifier that will make each instance of the entity, the instance of each entity unique, or in other words, a primary key. Now, this can be one attribute or a composite attribute, but in any event, we need something in that in each entity that's going to make each instance of the entity unique to all the others. And the remaining are descriptor or non-key attributes. Now, one important aspect of this is that each of those attribute names should be self-documenting. In other words, it should give specific information of what is going to be stored in that attribute. So if you have an ERD with 7 entities, you can't have the primary key on each of those entities called ID, because you just can't. It's not a good idea to have the primary key for more than one entity with the same primary key name or the same attribute name regardless. So it's better to have, if you have an entity called employee, then you can have employee ID as the primary key for that attribute. But in any event, it should be self-documenting when you start working on attribute names. So now this is one aspect that we'll take a look at. These are composite attributes that contain multiple values for one attribute. For instance, the employee address will have street address, city, state, and postal code, and that's all in one attribute. And again, this is to keep everything simple, and we'll kind of break that down later. Those attributes will break out into multiple attributes later on when we convert that into a database. But this is a composite attribute containing different components within that one composite. So let's we've spoken briefly about the relationships and the cardinality between the entities. Now, again, our text in some of the diagrams shows relationships with little diamonds between the entities and showing what the relationship is in that diamond. We're not going to be using that. We're going to be using this crow's foot notation that shows the relationship between, or the cardinality of the relationship between the entities. So, for instance, now, by the way, all of these relationships are binary relationships. There are effectively three different types of relationships that we will see in this class. Unary, which means that one entity has a relationship to itself, and then binary is the primary type of relationships that we're going to be dealing with in this class, and ternary is a relationship that is related to three or more entities, and you want to avoid that at all costs. If you have a ternary relationship, you need to do what you can to eliminate that ternary relationship, and for instance, use a bridge entity to bring all that stuff together. But in any event, this relationship between employee and parking space is a one-to-one relationship, and this means that one employee is going to be assigned one parking space, and then from the parking space perspective, a parking space can only belong to one employee. And for the relationship between the product line and product, you notice that it's a one-to-many relationship. And in that, you see that one product line can contain many products, but each product can be only associated with one product line. So that is a one-to-many relationship. And now, again, this is a many-to-many relationship between student and course, and the relationship is called registers for. And you'll see that one student can register for many courses, or one course can be registered into by many students. So it's a many-to-many relationship. And again, we can use that in the initial model when we're presenting that to the upper echelon, but we eventually want to break that down and insert a bridge entity that will eliminate that many-to-many relationship. And these are the cardinalities continued, and this shows mandatory or optional cardinalities between entities. For instance, we have a relationship here between employee and project, and you'll see that this is a many-to-many relationship, and one employee is related to project, but you'll see that just because you have an employee, not all employees are going to be assigned a project. However, if you have a project, there has to be at least one employee assigned to that project. So that's kind of how that works out. Make sure that you use this. Whoops, sorry. Make sure that you use this type of notation to identify the one-to-many and the proper cardinality, whether it's mandatory or optional, on both ends of the relationship. So, and then we get into enhanced ER model, and this talks about the supertype and subtype, and this is a little advanced. I was kind of hoping to cover this a little later on, but the text covers this week. So effectively, you have one entity that has a primary key and a number of attributes, and then associated with that, you have subtypes of the same entity. So you'll see that we have employee as one entity with an employee number as the primary key, and employee name, address, and date hired. And now all of the subtypes, which are hourly employee, salaried employee, and consultant, all of these subtypes inherit the attributes from the supertype. So the primary key for the supertype and all the subtypes is employee number. And then, and again, it inherits employee name, address, and date hired. But the attributes for each subtype are going to be different, because for the hourly employee, you'll have hourly rate, and then salaried employee, you'll have annual salary and stock option, and then consultant, you'll have contract number and billing rate. So, and again, these other subtypes and the supertype do not have these attributes. It's only for the subtypes. Okay, and now when you have the supertype contained in an existing ERD, it's going to be it's going to have a relationship with other entities in that ERD. So now you'll see that that since the responsible physician is related to patient, this entity has a similar relationship to all of the subtypes beneath it, or to all the subtypes beneath patient. Now you'll also see that patient has a subtype called outpatient and resident patient, and the resident patient has another associated entity that is called bed, and it has a bed ID. And now that is only associated with the subtype for the resident patient, because only the resident patient needs to be assigned a bed. But at the same time, it still has the cardinality of a 1-to-1, and shows whether it's mandatory or not. And I think that's all I need to point out on that one. But be very careful about how those relationships are structured, because it can get kind of confusing. So I think that's all I have on this week's material. Again, I'll be posting the another video from another textbook that covers the same material, but it's a little deeper. So I might have missed something in this week's reading. If so, please let me know, and I'll cover that. Thanks a lot.